As you sit now, your blood, your heart is pumping on its own continuously. You're not aware of it. In fact, you're not even supposed to be beating unless you have some other called palpitation that make you aware of beating. Unless you are lying in a flat position and in contact into some hard surface, at that point, because of the transmission of the sound, you could be able to hear your heart beating. But generally, you are unable to hear your heart beating. But it's beating continuously, is what keeps you going or making you alive. And the heartbeat is originated from some 2 points in the body, or specifically in the heart. We have areas that we call them the origin of the impulses. And the first one where the impulses originate is what you call the sinoatrial node, or the SA node. For other terms or other reference material, you call it the pacemaker, because that will keep your heart pacing. And that is where we have some specific types of cells that are excitable. Later, toward the end of this week, we'll review another sessions on the contraction of muscles, and we'll be able to see exactly how does the SA node is able to generate an impulse. That will handle in that session. But for now, just know that the pacemaker part of the heart is the SA node. So that part is located on the right atrium. And just below it, because of the contraction or the rate of contraction or the rate of impulse generation per second, that will determine the rate of the normal heartbeat. So the heartbeat rate originates from the SA node. Just below it, at the base of the still right atrium, we have the FE node, the atrioventricular node. It's a region that slightly moderate the impulses from the FE node. It could later increase it slightly or maybe reduce it a bit to ensure that you have your stable baseline heart rate that you have right now. Below the FE node, we'll go to a small region called the Purkinje fibers, which will later relay the impulses into the ventricles. And from the Purkinje fibers, we'll go into the left and the right bundle branches, which will supply the right and the left ventricle, and that will ensure that the two ventricles contract. So you have just an animation here from your screens. I hope you're able to see it. We have the SA node here, and we have the AV node here. So the impulse is generated, transmitted, or carried forward into the AV node. We have a small region there made up of some bundles called the bundles of E's, which will later subdivide into the right and the left bundle branches, which will ensure that the ventricles contracts and pumps the blood out. And that one forms the part of what you call the cardiac cycle. The impulses being generated from the heart, we can be able to record them and transform them from an electrical impulse into something readable, either you can see in a screen or we should be able to print it on a paper. And we call it the electrocardiogram, or simply in short, the ECG. So it involves placing some sensors, which we call them electrodes, across every part of your body, and they will be able to pick those impulses, which are simply electrical signals generated from your heart and transmitted into the rest of your body via electrolytes. We know electrolytes are good conductors of electricity, and much of your extracellular fluid is made up of electrolyte. These impulses will be picked, and they are very weak, so they have to be amplified or increase the frequencies of that one into something readable. And once we record that wave or that electricity in a paper form, we end up with what you call the ECG tracing, that you can either be able to see it in a screen or you can see it in a paper. And it looks something like this, which I think you're all aware of that one. I saw someone, I think maybe in your class, who has a tattoo of an ECG pacer that was badly drawn. And I meant to have corrected her that it was physiologically incorrect. It's made up of these parts. We label them using some alphabet, but for some reason, the person who started it initially decided that we should start labeling from letter P and not letter A. And we still stuck with that one for over around 100 years plus so now. So we have what we start from letter P all the way to T. So letter P, which is the start part of it, is just a slight increase in the amplitude. And that one represents the impulse or the electrical signal that is released when the FE node releases a charge, and it causes the contraction of the atria. And we call that process depolarization or simply contraction. It will later be followed by this other wave that is made up of three parts, the Q, R, and the S. And each part of the QRS, we call it the QRS complex, represent three waves that are joined together. And all three waves simply represent the ventricle contraction. And we still call that one the process of depolarization. After that, as you can see, we have another peak, and we call that one the T wave. And the T waves represent the ventricles relaxation, or what you call repolarization. So those are the three waves. So we have the P wave, the QRS complex, and the T waves. And usually it appears this way in a normal beating heart. And once we count it and we know the number of these boxes, we can be able to count and see how many of these waves we have in 10 boxes. And we multiply them by a factor because we know the gradation or the subdivision of this paper called the ECG paper. And you can be able to calculate the heart rate only by counting them and dividing them using some other factor. But so the distance from P to Q represent a distance that the waves take from the AV node all the way until it reaches the bundle block at the ventricles. And that duration can be increased or reduced, and some pathological condition develops from that. So as a procedure for ECG tracing, we use a 12-lead ECG, which I hope by the time you went to your lab practicals in most, I hope you have been taken through this one. And if you are not been taken, don't worry. At the hospitals, you have the ECG machines, and it's a skill that you learn as part of any other nursing procedure, but you classify one's nursing procedure. Doing it is one thing, but learning on how to interpret it is also another thing. But by simply knowing how the heart operates, form the basis of it. We connect the electrodes into the three limbs, that is the right, left hand, and the left leg. And then the right leg will usually tend to act as our heart. And then we connect other six across the chest using some specific positions that I think you should learn. You should be taken through it as a procedure on its own. But through the six lead, we call them the precordial or the chest leads, and the three limb leads, you are able to get all the impulses and record it on paper.